So now that we've finished in the design workspace and we've developed some of our bodies, we're going to move into Generative by clicking on the workspace drop down menu, and then we're going to click create study. When in this workspace, we can see the user interface isn't too different in terms of layout. Still have the browser to the left and all the different tools and functions along the top. And when we're doing this, we're going to try and stick to the left to right workflow along the top. This will help us ensure that we've set up everything we need. So first of all, we're going to set the study settings. This option allows us to control how defined the mesh and calculations will be. The more coarse, the quicker the study will be. However, the higher the resolution, the better the quality of the outcome. Next along our list is edit model. Now we're going to use this option to create the obstacle geometry for our other ring. For this, we're going to select obstacle connector, which allows us to place obstacle geometry in and around areas where we know we're going to have connectors like screws or bolts. So once we've selected that, it's going to ask us to select the start and end of the shaft. In this case, it will be the inner diameters of the ring. Along with the connector itself, we can also add bolt heads, and also we can give it an extra bit of clearance if there's any tools that we need to get in order to tighten up those connectors. So for this, we're going to select bolt head and we're going to add an obstacle geometry that matches the other ring that we've already made. Make sure that we click on both sides, and finally we're just going to click OK to add those. Now that we've got all the bodies we need to identify what is preserved geometry and what is obstacle geometry. To identify the preserved geometry, all we need to do is select the tool and then the bodies that we need to keep. You can either select them in the design itself or from the browser. As the body we've just made was through the connector tool, it automatically recognises this as obstacle geometry. To add another part of obstacle geometry, simply do as we did before, but just this time with the obstacle tool. Next, we need to move on to the design conditions. These are the parameters that the component would naturally work under. The first one is to set the constraints, and these identify where the model is locked in place or how it will be attached to another component. For this, we're going to set the inner circle of the bottom ring as a fixed constraint. Then we're going to apply the forces that it will be working under by selecting structural loads. In the dialog box, we can then set the stresses that apply to these bodies by choosing the direction, the type of stress, and also the magnitude before clicking OK. On this model, we're going to apply a 1000 Newton force downwards, along with 50 in each direction sideways. And we're going to apply this to both of the green rings. After that, we can set the design criteria by choosing the main objective of the component, whether that be to minimise mass, which could be useful for projects within aerospace, motorsport, and so much more, or we could choose to maximise stiffness, which may be useful for civil engineering, architecture, and the likes of those. The second aspect of design consideration is the manufacturing. This allows us to decide on which methods of production would be used to produce the physical model, along with some controls for the machining. And this is important as we don't want to be given an amazing design and then just realise that we can't even actually produce it and it doesn't get past just being on the computer screen. The manufacturing materials can then be chosen. Here we can choose them from different libraries in order to match the manufacturing we have chose. But for this example, we're just going to use the entire library to find our materials. You can select up to 7 different materials per study. Generally, it would be sensible to stick to materials similar to the ones on the model. So for this study, my 3 main choices are going to be Inconel, stainless steel and aluminium. But it doesn't hurt to add a wildcard or 2 into the mix. So we're going to add PAEK, which is a high-strength semi-crystalline plastic, to our study here. Once we've reached this stage, we should hopefully be ready to go. But just before we send it off to the cloud, we need to make sure it's completely ready by doing a couple of quick checks to ensure we don't send it off for a study just for it to come back with a fail message. The first part of this is to click on the pre-check tool. This will check for any errors within the study that we've set up. Any of those that are in red will mean the study cannot be run, and it'll also give us some information on why. Yellow warnings mean that there are some warnings, but these are more or less things to consider as opposed to it not being able to run the study. If this is green, however, then there's no warnings and we're good to go. Now, even with doing this check, there's still a chance that it could return something that we haven't intended for the model. Now, that could be because we haven't set up the study properly. So another quick check that we can do is to use the preview tool in order to give us a general idea of the shape of the model that can be created. You might have to leave this running for a few seconds, but then once it's done and it looks like it's taken shape, just simply click stop and we're ready to go. So now that we're happy with things, we can begin the study simply by clicking generate. As shown, this will take up credits, which costs money, depending on how many materials we choose. But when you think about being able to get such an optimized model being generated by AI within a matter of minutes, as opposed to engineers taking weeks, if not months, to make each iteration, it completely makes sense to use this, and you can see why it's going to be a major tool in the future of design engineering. Now, as Fusion uses cloud-based computing, we're free to carry on working on any other models that we've got going on, or we can just go and get a nice, well-earned cup of tea while we wait for the programming to do all the hard work.